So in this video, I'm going to talk about the calculus of logarithmic functions. Specifically, we're going to talk about how to take the derivative of any logarithmic function, and we're going to talk about the related integral of that answer. So, for example, I'm not going to talk about the integral of all logarithmic functions just simply because a lot of those require additional techniques of integration we just haven't done yet. So I'm just going to stick with the first basic one that we need to go over. However, before I get into any of this stuff, I do want to make sure that you've already watched the previous two videos. The first one is the calculus of inverse functions. Then you need to watch the calculus of exponential functions. This is the third one. This requires the other two. So I'm going to start off by doing the natural logarithmic function, which is ln of x. Recognize, please, that this is log base e of x. We just shorthand it as ln of x. In order to find its derivative, I'm going to treat it like it's an inverse function because that's actually what all logarithmic functions are. They're inverses of exponential functions. So ln of x is the inverse of e to the x. And so I'm going to use that fact to find its derivative. Otherwise, it's going to be almost impossible to do it using algebra. So when I go to take the derivative of the natural logarithm of x, what I'm going to do is I'm going to take 1 over the original function, the inverse of the natural log, which is e, to the exponent of the natural log of x. So I'm just following this formula down here. The derivative of e to the x is e to the x, and I'm plugging in ln of x into this function. Okay, now if you paid attention to the last video, the exponential functions video, you will hopefully notice that e to the power of ln are opposites, they're inverses, they undo each other. So what's going to be left over is just 1 over x. So if I have ln of x and I take its derivative, I get 1 over x. Now, before I move on, I do want to mention a couple of other important bits of information, and I'll use this color, is the fact that the domain of ln of x is strictly positive numbers, so not 0, not any negatives. However, the domain of 1 over x is any x but 0. So we have a little bit of a contradiction here, and just the way we do that is what we'll do is we'll restrict this 1 over x to just being positive numbers. We won't use any negative x's in there in the derivative. That's just an important fact to go over because it'll come up again when I talk about the integral in a second. So now I'm going to talk about the general logarithmic function, which is log base b of x for any base that's positive and not 1. So there is a thing called the change of base formula, which is what I'm going to use first, which just basically says that if I have log base b of x, I can change it to whatever base I want it to. For in this case, I'm going to use e. And what I'm going to do is I'm going to take whatever I'm doing the logarithm of, in this case x, divided by the log of the base, which is b. So I can do it with base e, doing the natural logarithm. I could do it with the common base, which is 10, and do log x divided by log b. I could do it with really any base that I want to. So if I wanted to make it log base 3, I could do log base 3 as long as I follow this rule. Whatever the logarithm of goes in the top, whatever the base is goes in the bottom. But again, we just found the derivative of ln of x, so that's going to be the one I use. The other thing that's important to point out is, in this case, ln of b is a number. If I take the natural logarithm of a number, I'm going to get another number. So that's technically just a constant down there. You can pretend it's a 3, a 5, or whatever number you really want it to be. So when I go to take its derivative, it's not actually going to change. All that's going to happen is I can treat this, let me write that down for a second. I can treat this like it's 1 over the natural log of b times the natural log of x. And so now, again, this is just a number. So I can keep that out front like it's a constant multiple, because that's what it is, times the derivative of the natural log of x, which is 1 over x. So my final answer here will be 1 over the natural log of b times x, or you can change the order and do 1 over x times the natural log of b. However you want to write it is fine with me. Again, that's kind of a neat fact to talk about is, in this case, if you think back again, watch that exponential functions video, what we did was we multiplied by the natural log of b. In this case, we're doing the opposite. It's an inverse function. We're dividing by the natural log of b. Now, let me go back to what I was mentioning earlier about inverse functions and integrals here. So, especially in this case, we mentioned that the domain of the natural log of x is just numbers greater than 0. However, if I take the domain of 1 over x, it's any number positive or negative except 0. So the question is, what happens if I try to integrate 1 over x dx? Well, in this situation, I'm starting with the derivative, and if I integrate it, I should end up back at the original function. However, again, the problem comes down to this conflicting domain issue, because I can plug in positive numbers or negative numbers into 1 over x, but I can't enter the natural logarithm. And that's where we're going to use absolute values, okay? So in this situation, it's important to use absolute values here, which makes it so that I can do any positive number or any negative number in that natural logarithm. So this is how it's going to work when we do integrals. I will mention that we don't typically do an integral with just this change of base, this generic base, simply because it's pretty much the same number, or it's pretty much the same function, 1 over x, just with a constant tacked onto it. So we really don't worry about that. The one we worry about is really the ln of the absolute value of x. So let me just kind of recap real quickly again. Um, the derivative of ln of x is 1 over x. If I integrate 1 over x dx, we get the natural log of the absolute value of x plus c. Again, we kind of restrict this domain to x being greater than 0. This domain should be x is anything but 0, so I could try positive numbers, I could try negative numbers. If I take the derivative of the generic base, log base b of x, we get 1 over x times the natural log of b, or you can again switch the order and do 1 over the natural log of b times x. Again, we're going to come back to taking the integral, of a logarithm, because that's something completely different.